Hello everyone. This is a video about how to use NVIDIA Nsight system to profile a training application. So in this video, I'm going to talk about how to use Nsight system and how to find out a bottleneck on the training pipeline, and specifically want to uh, change, like doing some minor modification, like the num workers, to make the whole training fast. So let's get started. So here we have a minutes model. I mean, here we have the minutes training model, and so this is the whole training pipeline, and we have the data set from the PyTorch, and use data loader to load the data. And also I have a training step and test step at each Apple. So for the default parameters, I'm setting the Apple number to 3 and training it on CUDA. And also have batch size 64. And so for the initial number, I want to set this num workers to 0. So we can see what happens if we change this one later. Um, so the next thing I want to talk about is the Nsight system. But before I talk about how to use the Nsight system, I want to introduce a model called NVTX. So this is a library supported by Nsight system. We can use it to doing some very useful stuff like annotate the function or a specific line we want in our application. Like for example here, we want to annotate this forward function in our model, and we can just do something like a decorator here. And this is just very easy to use. And also, if we want to annotate a line here, we can also use something like a with. Right? This is just a very convenient function, a library to use on our Nsight system. And then I want to look into the documentation of the Nsight system. So this is the official site from the Nsight system, and I'm looking at the command line document, which is the CLI, which I find is pretty easy to use. And so it supports the nsys command. It supports a few command like this one listed, and specifically we only use the profile in this video because it's enough for us to generate a report. So let's look into this profile command, and we can see there's a bunch option provided by this command, and we want to see where the NVTX is supported, and it actually lies on the trace part, which is -t. Let's find it. It's here. So this trace part, it does is like it will show you the what's happening on GPU if you type in CUDA, and ATX is something like I mentioned before, and also a bunch of libraries supported. And additionally, I want to add the OSRT because this is the operating system runtime. So we can just use these three to generate a very detailed report. And let's get started. So I'm going to do a little demo here. So nsys profile -t on ATX and cooldown OSRT. And also we can specify a output directory we want for the for this report to be generated. And here I tapped num worker 0 to be the report's name. And then we just type the application name. And this will just, after some time, it will generate a report, but I'm not gonna wait for it. And because I've already generated before I make this video, so I'm going to open that for you. So this is a very useful tool, an NVIDIA Nsight system. It's a it's a GUI. It's a GUI, and it can open the file we just generated. Okay, so as we can see, the NVTX library is here. And we can see our annotated function, like the forward, backward, and optimization step, which is blue, red, and green. And if we want to look at this whole pipe, we notice that there are just three blue portion, which means there are only like the forward is being called. And this could be our test step. This is our test step because during the test step there's no backward and optimization. So so this could be our test step, and there's like three apples. So it's easy to tell that these three are those apples, and these are the training phase. So if we look deeper, if we look into the training phase, we will discover the exact three functions we have labeled: forward, backward, and the optimization step. And beneath those functions, we can also see a bunch of CUDA kernel launcher called by our CPU. So this is the actually code which is going to be run on CPU. So whenever uh, we write our Python application using PyTorch and run and labeled it the model to device, like to the CUDA, it will generate those GPU kernel calls. And all those kernels are going to run on GPU and make the training pipeline really fast. So this is what's happening below. And as we can see, the forward function, they all generated some bunch of kernel, and the backward somehow it's launching kernel on another thread, and this could be because of some PyTorch feature. We don't know that yet, and that's it. But we can also take a look at what's happening on a GPU. So all those things could a CUDA API called by CPU, like they're just launching a kernel. But those things are really something running on GPU. Those kernels, as we can see. As we can see, they're pretty dense, which means the GPU utilization is good. Because we can see there are just little gap in between each iteration. So this means if we have a good GPU utilization, which means our deep learning application is written well, because you can hardly optimize anything if you have a 100% GPU utilization. I mean, whatever you write, it's going to wait for the GPU to finish executing, and then it's going to execute after the GPU. So 100% GPU utilization is good. Just remember that. And we know that our training work, like the training phase bottlenecks lies on GPU, and it's fine. So let's move to the test phase. So if you look at test phase, we'll find out that there's only forward function, which is a must because we don't have backward optimization in our test phase. And we can see that the CUDA kernel is executed here. And we notice that there's an interleave between the CUDA finished executing and before the next iteration begins. So this makes the CUDA utilization not like 100%. It's barely being like probably 60%. This is not good because we know that the bottlenecks is not on GPU this time. It's probably something on the host device. And what could happen in here is something we need to we need to study so that we can make at least the GPU utilization to be better, so we can make the pipeline faster. So if you look at the training pipeline here, so this is the test phase, and we can see the pipeline is essentially loading the data from the data loader, and then it will copy the data from the host memory to GPU by doing this to device. So we can try to find where is this one being called. So if we just try to discover it, we can see that there's something like a CUDA memory copy async. This is where the to device is being called, and this only takes like that much of time. It only takes about like very little time. You can see that the memory copy is better take any time. So what's happening before the device call and after the execution? We can just go back to our pipeline and see what's in between. So after the model is get its predicate prediction, and it will execute these two functions. And these two functions will not take a long time because it's executed on GPU. So as long as the predicate not being copied from GPU to CPU, these two is not going to take a long time. And we can just check it out to see whether there's like a memory copy from the device from the GPU to CPU to see if it's going to copy this one. And we didn't find it. So after this forward function, there's like not gonna be a call to map to copy the memory from the device to host. So we know that there's no memory copy, and this two one is just executing on the GPU, which is good. And then we just go back to this loop, and we know that the bottleneck lies here. This is the only way where there could be something slow because of the data loader. So if we think about how data loader is doing, it's like copying data from the disk to memory. And this step could take a long time. So this is our assumption. And if we try to see whether this is the assumption, we can just use num worker equals to 2 to see. Because num worker equals to 2 means that there will be additional worker helps you to prefetch those data from the disk to memory. And whenever you want to use it, just pop it out. Because the memory lies on the memory. I mean, the data lies on the memory. It's not gonna be too slow. You don't have to move the data like from the disk, so it's gonna be quick. So let's try to run num worker equals to 2. And again, I'm not going to run it because I've already generated that report. So let's just take a look at the generated report. So let's go into the test phase again. And we can see there's just a huge difference. I mean, look at the CUDA utilization. There's only like 0.3 milliseconds between each one was launched. And look at this one. There are about 2 milliseconds. So the CUDA utilization is better. I mean, much more better. And how's that happening? Because as we mentioned before, the 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 data loader prefetch take effect. So if we look at this one, if you look at the two device where the two device call is being executed, we can see that it happens during the GPU kernel is still running. And if we look at this one, this two device call is happening way after the GPU is being run. So after the predict call is being executed, we can see that it takes so much time for the the thread to move the data from the disk to memory. And if we use some worker, if we use the other worker to help us fetch the data, we only take this much time. And this is basically 1 millisecond, and this one is like 6 milliseconds, which is a huge acceleration. And after this call, the CPU would call CUDA stream synchronize. This one is basically means the CPU is waiting for GPU to finish executing, which means the bottlenecks now lies on the GPU instead of the host system. Yeah, so here, what I'm trying to say is, there's just a bunch of ways to improve the training speed and the test speed, inference speed. And the essential thing you need to look at is what's the bottleneck. And if the bottleneck lies on the GPU, then it's fine because you can hardly change what's running below. And if the bottleneck lies on GPU, which means the things is written well, and if you try to write in other way, it's barely gonna change something unless you you change the kernel being launched, like you're trying to use some less kernel or some faster kernel. Otherwise, you're not going to make this faster. So NVIDIA Nsight system is a great tool for this kind of profiling, and you can use it to um, visualize your training pipeline and see if something you can improve just by changing a number like non-worker and make the whole system fast.